calculator conversion identities. So the calculator conversion identities is a way to type into your calculator secant inverse of x without actually having the key. So on the calculators, we have a cosine inverse button, which allows us to find cosine inverse, but we don't have a secant inverse. So if you remember from the last example, we found out that cosecant of 1 inverse of 1 over x is the same as sine inverse of x. So this is a way that if you have secant inverse, cosecant inverse, or cotangent inverse, you can put them in form of cosine, sine, or tangent. Okay, so we're going to use this in order to solve problems. So for example, cotangent inverse is kind of hard to find, so sometimes it's easier to work in tangent inverse. So example 5 says, to determine an equation for the line tangent to the graph, y equals cotangent inverse x at x equals 1. So what we want to do is we want to find the equation of a tangent line. Well, we all know how to do that. We take the derivative, find the slope, do that, and then find the equation of a line. So I'm going to break it down into 3 steps that we're going to follow. So step 1 is that we're going to take cotangent and we're going to find the corresponding y value to this x value. So we have y is equal to cotangent inverse of x. And again, if you know what cotangent inverse of -1 is, then you can just go ahead and do this right away. But personally, it's easier for me to do a little bit of work and then deal with tangent. So this is f of x equals cotangent inverse. So f of 1 is equal to cotangent inverse of 1, which then is equal to pi over 2 minus tangent inverse of -1. Another reason why this is helpful is if we're not dealing with a familiar number like -1, 1/2, that if we're dealing with something like 0.85, then now we can use our calculators. So we get pi over 2 minus negative pi over 4. And the way we do this is we have to remember what 2 quadrants tangent inverse exists in. So here's pi over 2, here's negative pi over 2. And tangent inverse is over here. Right, this piece right here is tangent inverse. And so where it's -1 is right here at this point, which would be negative pi over 4, because the sine and the cosine are the same. So then we're going to get pi over 2 plus pi over 4, which equals 3 pi over 4. So that gives us the coordinate -1 comma 3 pi over 4. So now we have an x value and we have a y value. All right, step 2. Step 2 is the derivative to find the slope. So we want to find dy dx at x equals -1. So y is equal to cotangent inverse of x. So dy dx is equal to -1 over 1 plus x squared. If you forgot that, you can need to refer back to our derivatives of trig inverse functions. So then we get dy dx at the point x equals -1, which is equal to -1 divided by 1 plus -1 squared. So you get -1 over 1 plus 1, which is -1/2. So keep in mind, again, this is m. This is the slope at x equals -1. All right, and finally, step 3. And step 3 is to make the equation of a line. Y minus y1 is equal to m times x minus x1. So we just plug in all our pieces. Y minus 3 pi over 4 equals negative 1/2 x plus or minus a negative 1 so you get x plus 1. Now you can actually stop here, but I know a lot of us like to keep working, so it's negative 1/2 x minus 1/2 plus 3 pi over 4. Either one of these answers is okay. Again, for my quizzes online, I might set it up either way, so you have to be able to get both. Okay, so now I want you to determine the equation for the line tangent to this graph. It's very similar. The only difference is the x-coordinate. So I want you to try it on your own right now, and then push play when you're done. Alright, awesome. So you've worked it out. Let's make sure we all get the same thing. So f of x is cotangent inverse of x. So f of 1 is equal to cotangent inverse of 1, which is equal to pi over 2 minus tangent inverse of 1. So this is pi over 2 minus pi over 4. So you get negative pi over 4. Nope. You get positive pi over 4. So that gives our coordinate as 1 comma pi over 4. Okay, now for the next step, we take y equals cotangent inverse of x. We're going to find the slope. So dy dx is equal to 1 over 1 plus x squared. Dy dx at x equals 1 is equal to 1 over 1 plus 1 squared, which is 1/2. Don't forget, with cotangent inverse, there is a negative in the numerator. I almost forgot. So this is m. And now all we got to do is plug it in our formula. Y minus y1 is equal to m times x minus x1. So we get y minus pi over 4 is equal to negative 1/2 x minus 1. And again, you can stop there, but if you want to work it out, you get y equals negative 1/2 x plus 1/2 plus pi over 4. Again, either of these answers will work.